Is commercial PTT over cellular mission critical? Public safety embraced LMR for its ability to provide speedy and reliable narrowband voice communications at the touch of a PTT button. Push-to-talk over cellular, or PTToC, tries to emulate the behavior of LMR's PTT over cellular networks. Commercial versions of push-to-talk over cellular have been around since the days of Nextel's iDEN. One reason for the popularity of iDEN cell phones among commercial users. The ability to make PTT calls, you will remember, is a must-have feature for critical communications. Already, push-to-talk over cellular, over LTE, is being used to replace LMR in non-mission critical scenarios. LTE has the data rates and the speed to do this. But is push-to-talk over cellular or push-to-talk over LTE really mission critical? Three classes of push-to-talk over cellular exist, two being types of commercial product and one being an open standard. Carrier-based push-to-talk over cellular services offered by mobile network operators such as AT&T, Kodiak, Verizon, and Sprint are tightly integrated with their networks. Then there's over-the-top or OTT PTT over cellular products, each of which run as a mission-critical application over the top of a network and are therefore independent of any carrier network. Examples include ESChat, Harris Beyond, Tait Team PTT, and Motorola Wave. Finally, there's mission-critical PTT, MCPTT, which is the name of a 3GPP initiative based on the Open Mobile Alliance's OMA POC technology, which is used to define a mission-critical open standard for PTT over LTE. Non-mission critical users, as well as some public safety agencies, have taken up carrier-based push-to-talk over cellular as an alternative to LMR. You can see the attraction. It runs on standard smartphones, which are a lot less expensive than public safety grade radios. And instead of owning a comm system, an organization can purchase subscriptions and maintenance contracts from a commercial provider. Thanks to its tight network integration, this form of push-to-talk over cellular is fast, supports standard call types, and, maybe with an additional service, can tolerate a saturated network. But there's a downside as well. The integration of carrier-based push-to-talk over cellular offerings is challenging both technically and commercially. Engineering reasons can prevent the connection of a push-to-talk cellular from company A's carrier to talk groups on company B's network, and vice versa. The technical incompatibility of the two push-to-talk over cellular carrier integrations makes cross-network connection impossible. Commercial barriers also exist. Even when the two carrier integrations are technically compatible, they may be commercially walled off. Company A may not permit its subscribers to use its push-to-talk over cellular to connect to subscribers on another company's network. This is the business reality of protecting a proprietary product. Similarly, it is not uncommon for a company to restrict its offer of push-to-talk over cellular to a selected range of smartphones, even if other devices could be used if permitted to. This will not work for mission-critical users who need a fully interoperable service that can cross-network push-to-talk. Mission-critical requires something more open with performance and security that is better than the standard best effort service of commercial networks. Equally serious is the inability of carrier-based push-to-talk over cellular to support direct mode communication, which is direct radio to radio, also called simplex communication, and is independent of access to a network. Firefighters depend on direct mode to communicate with each other when they are cut off from their network. By design, carrier-based push-to-talk over cellular is always mediated by a LTE network. Over-the-top push-to-talk over cellular overcomes some of these issues. Running as an application over the top of the network, it is able to use the phrase carrier agnostic and does not depend on any specific carrier or device. You can therefore push to talk over cellular across networks with a wider variety of devices. Since nearly all OTT push-to-talk applications can work on multiple broadband access technologies such as Wi-Fi, LTE, and even 3G data on multiple platforms like Chrome, iOS, Android, and Windows, this form of push-to-talk is hugely flexible. However, once you choose your OTT application, you are then locked into a proprietary ecosystem where everyone needs to have the same application. This means that an OTT app from one vendor cannot directly communicate to another vendor's OTT push-to-talk system. This deprives mission-critical agencies of the ability to interoperate. Maybe some form of bridging or console patching can serve as a workaround, but the basic problem is the proprietary nature of OTT applications. Moreover, since OTT apps also need a network to work, they, like their carrier-based counterparts, are unable to support direct mode communications.